And so when you're ready, you can do your screen share.
Yeah. Okay. So are we going to share the image again, or we're just staying with NJAG logo right now?
Well, can you share right now? Your screen?
Just a second. Yeah. No, wait a minute. Just give me a second. Okay. Here we go. So we have the Hercules globular cluster Messier 13. It's roughly about 11.5 billion years of age and 22,000 light years distant from us at the moment. These stars are held together by their own mutual gravity. They cannot escape one another. So imagine multiple suns in every direction of the sky, and if you were a planet in orbiting one of those stars, you would have no night whatsoever. So the most of the stars are made up of very small red dwarf stars, but there are some blue stars in there. You can barely make them out in this image. Those are called blue stragglers. Essentially, when I'm going to dim this a little bit, you might be able to see the other stars here. The bluer stars. Bring it back up. You kind of can't with the resolution we have. But some of these smaller stars have combined to form blue stars because they increase their mass. Now they're burning brighter and hotter and larger than before. So the instrument we're using right now to look at Messier 13 is a Celestron C8 on a little SE mount. The image is stacking. The exposure time is only 4 seconds, but if you look over here into the stack information, we've stacked them 90 times already. So it's like 3,600 seconds. Sorry, 360 seconds rather, that we've accumulated. And it's better to take short exposures if you're using a mount that doesn't have perfect tracking, as opposed to a mount that has extremely good tracking. So Kevin, you have anything else, any other interesting information about Messier 13 that I may have missed?
Well, it just, of course, that's one of the nicest globular clusters in the northern hemisphere.
Right, it's kind of the best one, actually. You know, the other one might be, if you're down by the Florida Keys, you might be able to see a Mega Centauri. But this is...
Yeah, Mega Centauri is really spectacular. I've heard, I've never seen it.
Right, right. So Omar, do you have anything else on your scope now, or are you still on?
No, I'm still trying to work this through. So
okay, let's save this image here while I'm at it. Just a second here. So what we're using here for a camera, this is the Attic Infinity. It's a color camera. So this is a camera that's mostly used for EAA, which is what we're doing, electronic assisted astronomy. So this type of work is not actual astrophotography where you're doing, 60 hours of post processing and making the image as pretty as possible. But this gives you, I guess it's like, and think of it as an enhanced eyepiece. You can see much better than with the human eye. You can gather images over time, and you can stack the exposures. So this is as near real time as possible. I think some of these other stars, as they stack, some of these fainter stars are starting to come into view over here. There's one of the blue ones. Finally, they're starting to get resolved. So that's the other thing too. As these images stack, the resolution will continue to get better and better. It's Mary Lou West. Let's see. That Mary Lou? There's Mary Lou. Hello there. How are we doing?
Okay,
All right.
I need to mute.
Go right ahead.
Okay, yeah, we are live on YouTube. It is broadcasting, so it does seem to be working, so that's good.
So is this something we can look up later and play again?
Yes, this will be, I have it marked as public, just
Great.
so people
No,
can
that's
look at
good.
it.
So that's something we could probably even share on the Facebook page then, that we did this. So so Mary Lou, since you're coming in a little later, so this is if you look up at the screen over here, this is telling you the exposure time, which is 4 seconds. And these are being stacked. So this is 133 stacks of these 4-second images. And you can see it's rejected about 38 of those. Mostly because I'm sitting here on my my deck right now. And so there are some vibrations coming out of maybe the floor or something when I do make a movement. But so the program automatically throws out the bad images, which is kind of nice. So Omar, do you have another image or another object other
No,
than 13?
I may have to go out and change the filter on this one. This is
Okay, yeah. So if you could do that, that would be great, because if I move to something else, it may take me a while to line it back up again. So if we could switch to you and you can show us something, that would be pretty cool. But meanwhile, as the program continues to stack more and more, you can see some of these fainter stars are now becoming better resolved. This is the optical train is running at f5 right now, FYI. So it's it does have some focal reduction. So it's not native f10. Allows you to take the image a little faster. So is there anything else anyone would like to look at? You know, I could probably go on to, we have a gibbous moon out right now. I could try to go and look at a galaxy. Getting a nice thumbs up from Mary Lou.
Yeah, why not?
Yeah.
Try something.
Yeah, so this is coming out pretty nice, better than expected. And you can see as I moved around a little bit on the deck, the reject frames have gone up a few. I can almost tell when I'm sitting still, it doesn't reject them, but when I move, it's rejecting frames. And you can set the rejection rate to like a 7 out of 10, an 8 out of 10. how bad the image is. So it kind of goes on a 1 to 10 scale. Omar, you've worked with the rejection thing a little more than I have. Do you have anything else that you could say about that?
No, I mean, you pretty much hit the nail right on the head. I mean, it's just gonna, like I said, it's gonna drop the bad stacks that doesn't
Right.
that based on the movement and whatnot.
Right.
But I'm gonna try to get on M51 real quick. Just give me a second.
Oh yeah, that would be lovely. But you
Yeah.
could see, like I've been taking these really short exposures and just letting the stack go, and you can see that 13 just keeps getting more and more resolved.
All right,
And so what I'm doing, I'm saving some of these images as I go. And I'm comparing them later on. So I'll be able to go back and see the resolution at, let's say, a few stacks versus, many stacks versus what's in the middle, which is kind of nice. So there's some folks that throw away or trade in their eyepieces and do only this. I don't know if I'll ever be that person, but this is surely a treat. Even under light polluted skies, and where Omar's location is, it's much more light polluted than here in Hopatcong, New Jersey. But these cameras just cut right through it, which is just kind of amazing. So even if you're in the middle of a heavily light polluted area, you can use this technology and still be able to see deep sky objects that we once thought, you had to travel many miles to a dark sky site to go see.
I'm sorry, Mark, I'm gonna go change this filter out.
Okay.
That HA filter is just got too much out.
Right. So I'm gonna hold out a little bit more on this, a little longer on this object. Omar is gonna try to get us, I think he said he was gonna get us the Whirlpool. I think he mentioned it was 51. And that's a nice galaxy. And he's using a different camera than I am. He's using an Attic Horizon monochrome camera. So everything will be in black and white. But monochrome cameras tend to have better resolution, and so you can see deeper than color cameras.
Okay. Well, if while we're getting situated for another object, we can try to show them where M13 is.
Oh, that'd be great.
So let me.
You have Stellarium up?
Yes, I've got Stellarium up now. So let me switch over to
Okay.
Stellarium.
Let me just save this one last image.
Yeah. Well, you can do that, but in the
Go
meantime,
ahead, yeah.
Here we are looking at the constellation Hercules here. And Hercules is pretty high up now. And of course, this is, what time is it? About 10:45 or so. And so if you face east and look up real high up in the east there is Hercules. And so you can see the 4 stars that make up what they call the keystone of Hercules.
Right.
And, most of the time when people show or like look at illustrations of Hercules, I can actually put that up for you. If you put up Hercules, a lot of times it's illustrated like this with his head down over here. I actually like to imagine it the other way, because these here is his shoulders. Mostly with most guys, your shoulders are wider than your hips.
Yeah, I
And so
agree with
there's
you
his
there.
broad shoulders of Hercules, and there's his hips, and his legs come down like this. The other leg comes down like that, and there's his arm sticking up. I don't know what's going on with his arm over here, but his arms are coming up on either side, and he doesn't really have a head, so you can imagine the head here, and that makes M13 run underneath the armpit of Hercules. And so that's where you look. If you use with Yeah, if you use a pair of binoculars, under dark skies, you can usually pick out this fuzzy little spot right in his armpit there, and that's where M13 is. So it's a pretty easy object to find.
So does that zoom in closer where you can actually see 13?
Well, let's see. I don't remember.
Yeah.
You can see that whether or not there's an image. Let's see. Let me see if I can zoom in here a little bit. There we go. Whoops. It's a little jerky because I'm trying to run Zoom and Stellarium at the same time.
Same time.
So here it is.
Ah, okay.
Sort of an odd image. I don't know why. Like a ring there. I'm not quite sure.
Right.
But that's where it's located. Right on the under the armpit there. So there we are.
Nice.
So, and we can also show you where we're going if we're going to go for M51 next, right? So let's zoom around and take a look at M51, which is right over here by the Big Dipper. Let's see, let's select Ursa Major here. And so we're facing the northwest. So here's the Big Dipper standing up in the northwest. And as you zoom in towards the handle, there's the 3 stars in the handle. And M51, whoops. Try that again. There's M51 right at the end of the handle, right close to that. That star right at the end of the handle is Alkaid.
Right.
And so it's very close to Alkaid. So right there, we zoom in. This is where M51 is located.
Wow.
So that's going to be our next target here, right near the Big Dipper. Go. And so I think Omar is still out changing his filter there.
You might be right. Let me. How's it going, Omar? Did you
Yeah,
Did you
guys. Yeah, we're having some. It's my turn for technical issues. Give me a second, just trying to get a.
Yeah.
All right. My focusing just went off. That's just give me a minute. That's looks a little better, but all right. Let me get back in. Let's see if we can find M51 now. Okay. All right. Now. Over, bring up SkyX. Find it. So,
I'm gonna get up for a second. See what other.
Yeah, Mark, you may want to try to target. For some reason, this thing is just something went off on the tracking
Not
again.
there yet?
Yes, I think something went off on the tracking. So I'm going to just double check tracking one more time.
Oh, okay. I'm gonna.
Apologize about this.
You any closer?
No, I'm going to check my tracking real quick. So just give me a minute.
All right. So I'm gonna just for a second here.
Take off again.
I'm gonna go on to 13. 13 is looking good, but 50 M57 hasn't cleared my roof yet. So once it does that, I'll be able to grab that for you guys. I might try. Let's see. Oh, did we lose the meeting?
Oh, I'm still here. I don't see Kevin. Oh, is Kevin still on? Hold on. I see Mary Lou and Kevin. Lost audio though.
Yeah, I'm still here.
Okay. All right.
Ah, I see Jay. Okay,
Oh,
Zoom.
I got my microphone muted, so
Ah, okay.
there we go.
Now let's try.
Gotcha.
I was checking our YouTube feed, and looking pretty good.
Ah,
So I had myself muted there.
excellent. Yeah, my Zoom screen got strange. Here for a second. What the heck here? What's going on? Yeah, it looks tiny.
Oh, did you? Yeah, the Zoom screen will kind of compact itself.
It did that.
Sometimes if you click on the, yeah, so you gotta. It's
Oh,
is it
exit
the lower
minimize.
right
Ah,
corner?
okay. There we
Yeah,
go.
minimize.
Much
It's
better.
minimized. There you go. Yeah, it hides
Ah.
all the controls on it. Hard to
Well, in
get
the
back.
meantime, I'm gonna go back and share. I still have 50. I still have 31.
Okay.
Let me see here. Well, Omar does that. So that 31 is still stacking away there.
13. I'm 13. Right.
So maybe while he does that, I will attempt to put another object in. I was gonna try 57, but it's not there yet. Yeah, let me maybe I'll
Not
try
high
50.
enough yet.
It's not. It hasn't cleared my house.
Oh, right.
It's
Yeah.
because
yeah.
I'm on my deck here.
Right.
It's got a little time yet. Let me go and look.
Mm.
You take the stacking off. Now watch. As soon as I take the stacking off, I bet you we're gonna see 13 move or be out of frame here. 300 stacks. Let me do one last save here. All right, say bye-bye to M13. I'm gonna go take stacking image off. No, it's still there. I only moved a tiny bit, so my tracking wasn't terrible.
Okay. Yeah.
Now you're gonna see. Now you'll see me bounce around and move on the deck. That's the kind of vibration that we have here. All right, so enter. So I'm going to try to look for Messier 81, but now you're actually going to see that the telescope is moving. You might occasionally catch a star or something.
Yeah. I see some stars streaking through there.
Streaking around the, yep, to the screen
Yep,
there.
there they are. A couple there.
Yeah, so the telescope is slewing around almost 180 degrees.
Oh, it's a white screen.
Well, I think because it just saw the moon.
I was going to say it's probably the moon.
It crossed the moon, yeah. So hopefully we get an idea. Hopefully I'm close enough to the galaxy. All right. Oh, good. Okay. It's actually not bad. That is M51. Not 51, sorry. 81.
Oh.
Oh, no. Where'd I go there? It's gonna take me a few here to get this lined up. When I have the equatorial mount out, it's much easier to do this. All right, so I have to see. Let me take my exposure time. Yeah. So you see how it's moving on its own? That's the backlash within the mount. That's how much play there is. After it's going to settle out in a minute. Now I'm going to move it on my own. Too much. That's not a good sound, Omar. What happened there? Let's see, did I go left or right? Nope, too far. It's almost centered. I gotta wait for this to balance out. Too much. So what you're seeing there is the core of Messier 51 right now. All right, so hopefully this will settle out. I'm gonna mess with the histogram down here. This is the exposure rate. So this is a slower optical system. This is F5. Last time we were using F4 and F2.9. All right, so I'm gonna now increase exposure time and start stacking the image. So now the image will hopefully get better and better as expose more and more of the galaxy. A little noisy there. Increase the exposure. Hold on. Yeah, Omar is using f3.9, so he should be able to acquire the image much quicker. I'm gonna go to 10 seconds now. And let's see what happens from here. So M51 is about 12 million light years distant. I'm only getting the core at the moment. I increase the exposure time. Maybe that might help a little. I'm just a little worried about introducing tracking errors if I increase exposure time too much. Try to stay as still as possible so it doesn't reject that many frames. So it stacked 1 and rejected 3. So that's telling me there's too many. I have to bring my exposure time down. So a slower optical system is having more trouble resolving galaxies. And I did expect that.
It was got quite a bit of got quite a bit of moonlight there. Or
That's
what,
true.
2 days past first quarter, something like that.
Yeah, it's 3 days. I'm looking at that moon
Almost.
now.
Okay, yeah, 3 days. Yeah, that's true. So,
I mean, there is a filter on here. It's an Orion filter.
Mhm.
Now let's see. So it's stacked 5 and rejected 3. So it's only got 2. Well, now it's got 3 stacks. That's another thing too. So if I'm trying to stay as still as possible here and collect more data. Omar, how's it going?
might be
I think
outside.
I was not. Sorry, I was on mute. No, this is this one's not panning out too well. I may have to switch back over to the to the infinity. Like I said, this is a new camera that I'm trying out tonight, so
Okay.
still trying to work things out on it.
So it's starting to resolve a little bit now. If we just be patient, some of these bands will come out. You know, when we see something like M57, the Ring Nebula, we might be able to resolve it a little quicker. So I mean, you know, the slower the optical train, the longer it takes to acquire an image. So I have two things going against me here. I'm using a slower system, and I'm using a mount that doesn't track as well tonight. I'm using a single arm, fork arm Nexstar SE mount. It's a 8-inch SE. So it's, I'm looking at this now. So we have 12 stacks and it's rejected half of them. So we only have 6 stacks here of 9.5 seconds each. So as this goes along, this will gather more data, but
And you're starting to see a little color.
a little bit, yeah, you're starting to see a little bit of that. Let me see if I can bring out. That blows out the center. I'm trying to see if there's any structure in there. There's some structure here and some over here. So this is a much bigger, larger scale than we had before. So if this scope were on the equatorial mount I used the other day, it probably would be much better. Yeah, you're starting to see right here, you're starting to see spiral bands here and here, very faintly, but if they're there. Very faintly. And they'll pinpoint objects like, yeah, it's rejecting about half of these. Exposures that are going on right now, which makes some sense. So the reason why it might reject an exposure is if the tracking is off, or it's some vibration from me sitting on the deck here. But this is Bode's galaxy. So if you, Kevin, in Stellarium, maybe you want to point this out to people where this galaxy might be, may reside as we stack more images. 2111, roughly half. It's rejecting roughly half of these.
Well, this is M81.
81, yes.
Yeah. 81. Go.
Yeah.
So yeah, this is also a galaxy looking in Ursa Major, but this time you're at the front of the Big Dipper rather than the handle. And so if you zoom in, it is right here.
Right.
This big, nice big spiral.
Right. So, Kevin, if
see,
you're pointing to those spirals there, those you could barely start to see that those spirals are starting to resolve out.
yeah,
a
so that's
little
what I'm starting to see some of the spiral arms come out.
Yeah, there's another galaxy right next to it, Messier 82. That one had a supernova in it not that long ago. Was it 2014, I think?
Could be.
Spot. Yeah. I guess that's long ago now. That's some 6 years ago.
Yeah.
But these galaxies are kind of close to the Big Dipper. There are a lot more galaxies in the southern sky right now, in Virgo and the area of Virgo, the Coma cluster. But just so happens that the moon is hanging out in that area. So I'm kind of staying away from that right now. You know, extra brightness from the moon.
So I guess a good way to find M81 is to go across the Big Dipper, the bowl of the Big Dipper. You know,
Right, like a diagonal.
diagonal across this way, out like this in front of the Dipper. That gets you in the
Yeah, so
general.
if you connect those, you know, Doobie and I can't remember the name of the bottom part of the part right now. The big,
Forgot that one too.
yeah, yeah. Connect these two together, and I get points right there. Yeah, it's a good guide. Here we go. Let's see how much we've done so far here. Well,
There we go.
yeah, there's some semblance. Brighten this up a little more. Yeah, it's blown out. You can barely see it. So if I had the other telescope, the F4 telescope, this would have come out a little better. And it's essentially the very similar telescope to what Omar is using right now. That did better. But not bad considering. So I'm gonna check and see if the Ring Nebula has cleared the house. A few more minutes and it will have cleared the house. It's not quite there yet. Oh, Omar, do you have anything yet?
Yeah, no, nothing's
No,
coming.
okay.
Yeah, sorry about this, but this one's
It's okay.
if I switch cameras, I'm gonna have to possibly do another alignment again. I don't know yet.
Yeah, I'm trying to see what else is up that's bright enough. Right now, just bear with me for a second.
Well, if you want to look at something bright, why not point over at the moon for a bit?
Could. I've never used this camera on that, but I'll have to. Let's give it a shot.
Just right out. Yeah.
Let's try. Solar system. All right, here goes. Okay, I'm gonna stop stacking because now we're on. Oh, look at that. Must be pointing at the moon. The image is super bright. I'm gonna lower the exposure time
Way down.
way down, 1/10 of a second. Huh, okay. Can we get any?
Crazy.
You know what I got to do? I have the wrong filter in here, don't I? So you can see that there's some play in the guiding there. Just bear with me a second here. Oh, wrong way. All right, give me 1 second here. I am gonna go and grab a, well, first I'll start with a moon filter. Give me 1 second, I gotta grab my other case. I might be able to take care of that. Okay, so I have two filters that I might be able to use. One of them is a standard moon filter, and the other is a polarizing filter, which the polarizing filter, you can adjust the amount of light that comes in. The moon filter, the standard moon filter is, you have one option, 13%. So I'm going to remove the camera for a second. Bear with me here. I'm removing the standard light pollution filter. And replace it with a moon filter. This is the first time we're trying this, so we'll see how this goes. And there may be some refocusing involved, I'm not sure yet. Maybe not. Well, that's an improvement. All that shaking is me moving. Okay. So the top of the moon is actually, we have an inverted image because the camera is technically upside down, but there's a reason for that. Can you guys see my cursor with the finger pointer?
Yeah.
That moves. So that's Clavius over here. So you have, this is a particular crater I love to use in some of our geology classes. And we try to look at what came first. Actually, you know what? I'm going to just see the exposure here. Let's see if I can mess with this. So I got the whole bunch of different peaks here. Oh, look at that. Oh yeah, look. Ah, wow. Isn't that neat? So Kevin, you tell me where, well, if we're looking at Clavius, it might be better to do. This is giving the whole moon a better look here. If I do this. Ah, what happened there? The black line disappeared. Oh, it's over here. Hold on, I found it. Oh, I thought I did. There we are. All right, so that, trying not to wash out the rest of the moon. Meanwhile, showing as much as possible. Yeah, bear with me, I'm experimenting here.
Always looking much better.
Yeah. So we're back to Clavius. Could try that other filter, but that's a lot of time. So right here, if you look at Clavius, we love to use that as a geology lesson because we have a lesson called Horizontality and Superposition. And, you know, principle of horizontality, you know, given everything, all else being equal, you know, gravity pulls everything down towards its center. So one layer of deposition is usually the newest layer of deposition of either it's sediment, soil, rock is always on top of older. And that's the thing that plays most right here. And so we try to ask students what occurred first in this order of sequence here. So the first thing was the largest crater, Clavius itself. Then there was the next event would have been it being filled with magma here. Although this part of the crater, there may have been an in-between event with this crater here is partially filled with magma, but yet it still sticks above the lava. And then the rest of these craters came afterwards. And it's unclear if these craters that tail off over here were part of the same event where multiple objects hit at the same time. So you have one older event with the largest crater, then the lava flow, and or this crater here, and then the rest of these craters impact the already dried up lava flow. So I'm going to save this image here. This is the first time I've actually put this camera on the moon. Moon 5. Let's see, 31. So if I had a slower optical system, you may even be able to see more. I mean, a faster optical system, rather. So I'm going to zoom on different parts here. So that's technically the bottom. Now we're slewing towards the upper part of the moon here.
This is the northern half we're looking at now.
Say that again, Kevin. I'm sorry.
The northern half we're looking at now.
North is down. Yeah. So this is
You can see off to the right. You can see a little bit of the
right. Right. And so it's upside down and inverted, I would imagine. Actually, no, it's just upside down. So is that crater over here? Is that Copernicus? I'm not quite sure. Yeah, I've got my orientation upside down here, so I'm kind of.
I think so. I think it's a little too early for Copernicus.
A little too early. Go look at my.
I'd have to pull out my moon map.
Yeah, I gotta do the same thing. I'm a little thrown off here because it's not in the orientation I expected it to be. Where are you? Oh.
Yeah, it's a little too early for Copernicus. I think it's just beyond the terminator at this point.
Right. Oh, it's Aristophanes.
Yeah,
Aristophanes. Yeah. Okay. wonder if I can get the focus in a little better now. Here. Let's see. No, that's worse. Oh. I think that's the best we're going to get it. So try to look down. So that's Mare Imbrium, this direction here. Let me try to bring this up. Ah. Yeah, oh, hold on. Tracking's doing some weird stuff here. So that's Mare Imbrium. Okay. Well, it's good to know this camera can do the moon. It's mostly marketed as a deep sky camera, but I guess it can do this too.
Yeah. So actually, with maybe with a polarizer on it, you might
Right.
be able to
Might get
knock brightness down a little bit more and get a decent image with this.
right. Yeah, and get it a little bit darker and a little more contrast.
Yeah, a little more contrast, but it's a nice view anyway.
Right. Omar, anything else? You have anything else up? No.
No, that's negative right now. I'm switching cameras over, and so it looks like I'm gonna have to do an alignment all over again.
Oh, okay.
Yeah. So
I'm gonna let me see if I can see if the ring nebula is above the
Right.
house yet.
oh, this is strange.
It might have just cleared. All right, I'm gonna try and take the camera out again and put the light pollution filter back in. We're gonna try to go for the ring nebula.
All right, let's do this.
Hopefully this has cleared the house. We're off to the races, folks. Let me start the stack, not stacking, but exposure time. You can see the zigzagging across here. That's my house, isn't it?
Yeah, I think so.
Which one are you going for, Mark?
I was going for the Ring Nebula, but it hasn't cleared my house yet.
Let me see if I've got any.
Hold on, let me look through the finder scope. I'm literally just there, almost there. All right, I'm gonna try something else. I can see Scorpius coming through the trees over there. I might see if I can get M4 in the meantime. It's a total crapshoot here. That might be Antares. Let me see there. That is not M4. Just bear with me.
Oh, I got the ring.
Oh, nice. Good.
Oh, I just need to clean this up. So if you want to see, it's
Nope.
you guys want to I can start sharing my screen if you want,
Go ahead, yeah.
because I'm still in the middle of cleaning this up, so just give me a second.
Oh.
But I can definitely let's
Yeah,
see.
share your screen.
Nope, the host has stopped it. Hey, Kevin. Want to unlock me? Kevin, you're muted.
I just stopped Mark's sharing.
Share, yeah. My screen went away. I don't know.
Yeah, I turned it off.
Okay, yeah.
Well, I'm sorry. I have you were messing around with your telescope. I had your video muted, so I think that's.
Yeah, I know. No worries. Yep.
Unmute. Start video.
All right. Start my video. So let's see. You guys are seeing this?
I see your face.
No.
What's that?
I see your face. That's it.
All right. Well, hold on for a second. Let me let me start my video. Okay, there it goes. Now let me share my screen. Okay, give me a second. All right, so you should be seeing this now. Mind you, like I said, I'm still cleaning this up. I've switched gears.
Oh, nice.
Oh, it's
Very nice.
Yeah, I got a lot of hot pixels in there, and using a very sensitive camera. I'm gone totally a different route here. So just
What camera is this?
this is the Cam DS432C. It's got a 9 point something microns. I can't remember. Yeah, this is a very, very sensitive camera. So it's I haven't put much time into it. All right, let me do this. Let's do this. I'm going to set this up. So let me get my region of interest. Let me just put this so I am fading to window. Okay. And let me get this set up. Come on. There we go.
Kevin, do you want to tell us about the Ring Nebula at all? What do you think?
Oh gosh, I can't recall the distance to every decision on top of my head here.
Right.
Um,
Let me look here. I might have that in my notes.
Yeah.
Mind you, I'm not even stacking this yet, by the way, guys. I'm just setting up. So
Gotcha.
Dawn, nice
Oh, we know Vega's 25 light years. Okay, the Ring Nebula is 2,300 light years away.
2,300 years away. So, this is yeah, pretty far out there.
Yeah.
Yeah.
Do we know when that happened?
Ooh, no. Yeah, I'm not sure. I don't think it was recent.
Yeah, it's over like 10,000 years or something, 6,000 years. Maybe it was something like that.
So this is in the constellation Lyra. So kind of almost in between the two bottom stars in the constellation Lyra. And so this is not too hard to find, and it's nice in the summertime. This is up high in the sky all through the summer. And so this is a nice object for the summertime. And this is what we call a planetary nebula, which is sort of an odd term. It's a kind of a misnomer because it has nothing to do with planets, really. But early on, when astronomers first discovered these objects, their telescopes were pretty small and they couldn't resolve them very well. And so you just saw this little blue or greenish disk in your telescope, and it kind of looked a bit like Uranus and Neptune. And so they were kind of looked like planets. So that's why they call them planetary nebula, but it has nothing to do with planets at all. So something like this is created at the with a star that is similar to the sun, has reached the end of its life and puffs off its outer layers, and that's what you see here is the gases that have been puffed off by a star. And somewhere down inside that nebula is a white dwarf star, the core of a star that's left over, and all these gases have been puffed off, and it's a nice kind of spherical look to it. And so that's why we call it the Ring Nebula, this little Cheerio in the sky there.
Awesome. Quite wonderful. Yeah, so we're looking at the future of our solar system. About what, 4 billion years, Kevin?
Yeah, something like that. 4 or 5 billion years from now.
4 to 5 billion years.
It might look something like this.
Right. Let me see.
Well, I'll let that sit there for a while because this is the one object at least I've had good luck getting.
Do you have a light pollution filter on this now?
Yeah, I've got the LPR on there. Yeah. Yeah, it's the actual LPDS1, I believe, something like that. Yeah. Yeah, I took off the H alpha. That's a little bit too much. I mean, how's that looking, guys? I mean, it's one object.
Good.
Okay.
Yep.
you can see this particular camera I'm using has quite a bit of granularity to it as far as all the different settings. So it's one that I use not as often. This is only at 3.4 second exposures.
Gotcha.
So relatively a quick acquisition with this setup, as Mark was explaining earlier.
I think we lost Mary Lou,
No, we did.
and we have someone in the waiting room who just lifted his iPhone, so I assume that's Mary
Oh,
Lou.
that could be Terry.
Oh, Terry, yeah. They just sent it to
Yeah,
me?
he just messaged me.
Okay. Let me admit him as well.
So in case you're wondering, I have M5 stacking away over here.
Hey, Mark.
Hey, Terry.
Is that you alone or you're with anyone?
We can hear you.
Barely, yeah.
Is that Omar?
Yeah, Terry, yeah, this is my screen you're looking at.
Okay, nice.
Looking at Omar's, yeah.
You're at Omar's, Mark, or you're home?
I am home. We are all at our homes, respective homes.
The whole point of Zoom, I guess.
Yeah.
Oh, that looks good. That was good.
And we've got that 141% magnification.
Uh-huh.
Let's see if we put that at 100. But I've got this set up at the particular region of interest on this image. So let me go put that to see what it looks like at 150. Yeah.
Looks good.
Yeah. I don't
Which
even think.
scope is that, Omar?
What's that, Terry?
Which scope?
That's a Explore Scientific Newtonian. It's about F4, F40, F39.
Okay.
Using
That's a nice picture of the moon, by the way, Terry.
Yeah, thanks. You know
Yeah.
something, Mark? It's taken me a day and a half to put all that scope together. And the next thing I'm going to work on, I balanced it, everything. And the adjustments I made have helped a lot in terms of the focus is working fine. I put it together wrong. So I had all that problem yesterday, but I figured it out, and it's smooth. And also I got a bit balanced the thing better. And tonight I collimated it almost perfectly, pretty well perfect.
Nice.
That's why I was able to get a good photograph like that with the thing. So that's what it's capable of. It's great. I was very satisfied.
Yeah, very nice. That was very good.
Hey, Mark, you want to share your screen? So I see what you got. You said you were stacking M5, right?
Sure. Yeah, I'm stacking M5.
All right. Well, I can stop.
Yes. Let me. All right. So we're gonna move over
All
to
right. So
Messier 5. Okay. That's
What are you
M5.
using, Mark? Are you using that ATIC or are you using the
This is
Evolution?
the Attic Infinity. This
Attic,
is
it?
Yeah, this is the same camera. Right now, this is on my the 8SE, just like yours.
Mm-hmm. That looks good.
Yeah, and this is reduced down to f5. This is
Oh,
f5.
okay.
Yeah, so this globular looks quite a bit different. A lot of stars look bluer than M13. If too bad Mary Lou left already. I'll send her that image. Let me see. I'm saving this image here.
Yeah, that looked really good. That looks really good.
Yeah, it's surprised.
Yeah.
So the infinity seems to. I mean, also we have the moon. I also haven't tried different filters yet, but it doesn't seem to do as well on the C8 with galaxies. I've noticed so far. But for globular clusters, the image scale is it's better. It's closer in.
I'm going to take a snap of this, and I'm going to see what else we can get to.
Yeah.
This right here.
Yeah, not sure the distance on M5, but I know Mary Lou did some research with her friend.
Successful night in the end.
Yeah.
Good night.
Okay.
No, I'm not. I wasn't talking to you, Mark.
Oh, okay.
Yeah.
One of her friends from AAI did some research with
Mark.
some variable stars within this globular cluster.
Nice.
Yeah. So far, because exposure time is only 3 seconds, we've only rejected 6 of these stacks. And it's stacked 76, 77 so far of these. It's taking a bunch of short exposures. Let me see if I can. No, that's too dark. Ah, there we go. I'm going to save this image. And we're going to go to 6. So Kevin, I found, my workaround for, my keyboard doesn't light up. And I had this little
If you can't see what you're typing, yeah.
Yeah, it's pain in the neck. But I had this, I had forgotten. I don't even know if Orion sells it anymore. But they sell this little red light that plugs into your computer.
I have one.
Yeah.
Oh, yeah.
It's
I got one.
a little bendy thing.
Right.
And it's able to project on those keys, so I can do that. So I got around that.
Good.
But so yeah, this is coming out nicely. I take another save of this. We're at 102 now. Okay.
So Omar, my goal is, I've been working on this big scope, this 16-inch Dob. When the planets come up in the summer, one of the things I'll be working on is the ZWO camera. That's my goal, is to focus in on the planets when they come up in the summer, and I'm hoping, I've got an 8SC which is working well. That's one of the ones I've been taking the Moon and Venus with. But I'm hoping to use because it's got very good mirrors, use the Dob and be able to use the ZWO camera taken. But I'll also use the 8SC. I have a refractor like you as well. I'm going to try to compare them, you know, see which ones bring out the best image. So that's my project for the summer.
Nice. Oh yeah, well you're gonna have enough to keep you busy, that's for sure.
Oh, I'll be busy, yeah. As long as we get nice weather like this, that's the main thing.
Right.
Let me take off this ROI real quick. Give me a second here.
So this is
For a default. Bring this over.
so you're still on 57 or?
No, I switched over, but
Yeah, what is that? It's nice.
Yeah.
which one are you on, Mark?
I'm still on M5.
Oh, that's the same one? Okay.
Yeah, this is M5. Yeah, it's just
Yeah,
been
okay,
stacking
looks
away.
good.
And this one is off an Ophiuchus. So we're now in the southern part of the sky. We're to the left of the moon. But again, you know, stars being pinpoint objects, they're easier to photograph than diffuse objects like galaxies and
Sure.
nebulae.
Sure.
You know, some people have tried combining focal reducers, like this particular f5 along with an f6.3, and they get it somewhere in the f4, f4.5, f4.2 range. That might help with galaxies, but that's an experiment for another day. But overall, I'm pretty happy with what this is doing in this scope. But I get what some folks have said, that this camera likes faster optics for the most part. Although, you know, for globulars, this seems to be doing really well, and you have a nice image scale. Almost at 150 stacks here now.
Let me try something different. Let's see, is this too low? Let's see, find it. Where are you? All right, let me try a little something.
Let me see if I think the ring probably has cleared my house at this point. But I think you've already been on it, so I don't think it's worth me going over there.
Look.
Oh. 27. Too far away. Yeah, I wonder if a darker sky would, without the moon, would help with the exposure on some of these.
Yeah,
Fainter.
you know, you've got a waxing moon there, and even though it's going down. You know, the
Oh,
light
still, it's
pollution was
awfully
so
bright.
bad. I found it difficult to find bright stars to be able to, you know, do the collimation with the stars.
Hmm.
I eventually found one, and that's how I was able to do it. But the pollution is really bad. I imagine it's the same where, you know, out this way.
Right. Yeah, the pollution doesn't help, but it's doing pretty good considering. The brighter nebula or not. Yeah, they're behind the trees right now.
Which one? What else did you have in mind?
Well,
Something to look at.
What do you have on your horizon? You know, the stuff that's at the center of the galaxy is behind trees for me at the moment.
Yeah,
I can't get to them.
I see what I got here.
And if you have something, that would be.
Let's see. Let's try. What do we have? Let's expand this and see what's available to us. That's too close.
M5.
It's too close to the moon, that's for sure. Should we go a little further this way?
Yeah, there are a lot of galaxies out right now, but I can't. They won't resolve very well at my speed without a lot of exposures. Unless I try changing filters, but that's a possibility too. But I can go move to something else. So out of 191 stacks, it's rejected 20 of them. So it's held on to most of them at this fast exposure speed, a fast exposure time rather, 3 seconds. Short rather. You got something cooking, Omar?
No, I got nothing yet. I'm trying to see what I can get. This moon is killing me over here. Okay. Let's see.
Save this. Just hit 200 stacks. Probably as good as it'll get. Yeah, as we get closer to the galaxy center, we find more of these globulars. So you're on your scope set up on your porch, Omar?
Yeah. Mhm.
Okay. So what sky do you have?
Right now I've got let's go. Well, Really, the best part of the sky for me is going to be northeast, northwest. I've got the moon on that side, but then again, I got a big giant tree blocking me as well on that side.
Right.
So, slim pickings.
Do you think you can get the whirlpool?
We could try. Let me. Let's see.
I'm gonna see if I can get 57 myself here. At this point, I'm gonna stop the stacking.
M51.
Stop stacking. All right, I'm gonna move over to I'm gonna try to get the Ring Nebula now. What star field is that? Not look like what I want. Okay. Aha. Okay. All right, that's 57. And that's me trying to move on the deck again. Okay. This settles down. This is why we don't put a dome on top of a building. Not anchoring it.
Yeah, man, I'm telling you, I can find M57 again, no problem. When I screw the M80, M51, I get nothing.
All 'Cause- 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 Backlash, settling out. Okay, so
All right, let's go.
bring the exposure time up a little bit. Let's see. Pushing exposure just to 7 seconds, stacking from there. So we're trying to ring nebula again. What happens here?
Guys, I'm going to sign off now. Got a pretty heavy day tomorrow.
You got it, Terry. Good to see
I'll
you.
let you go. Thanks for inviting me in. It was nice.
You're welcome. Yeah.
Yeah, good.
Have a
Yeah.
good night, Terry.
Yep.
Good
The
night,
ring
bye-bye.
is actually starting to come in a little better now. Look at that. It's up to 10 stacks now. And these are 7-second exposures. Just beginning to see the center star here white dwarf. Let's see how this keeps going. This is getting better. Let's see. So it's Act 23 and rejected 7 of these images. I think this came out okay. You know, considering the limitations of the system. Did you find it, Omar?
No,
No.
it's just not coming up. Yeah. Like I said, I went back to M57, came right up. You know, dead center.
Not sure if you have anything in your histogram you gotta adjust. Maybe. Huh. I'm clipping. Well, almost. It brings it a little bit unnatural, but midpoint. Well,
Let me take a look at something.
huh. A lot of stacks just got rejected. I wonder if we just had a breeze here. Interesting. More than half of them are rejected.
Right, 20 seconds. 15 on the game. Okay. All right, so let's do this.
31 stacks, only 21. So it's only like, it only has like 11 stacks that it took.
Okay, let's do this. Now,
I just increased the rejection, so it has a better chance rejection level, or decreased it rather.
and 51. Find it. See to it. Okay. All right. All right, and let's
Save that.
move this and see what this looks like.
Yeah, you can definitely begin to make out that central star right there. It's doing better now.
Yes.
I'm starting to pick up some definition.
Let's try this guy over here.
You got something now?
I'm going to try to go after 102 or 101, one of the ones, see what I can get. Okay. Let's bump that up. Okay, let's do this. All right, let's start getting this game back up. Okay. Bump that up a little bit more. A lot of green in here.
Any luck?
No, I've got a lot of green in this in this photo. Hold on. No, nothing yet. I'm just try adjusting the game a little bit and see if anything comes out at me. Nothing. That's so strange. See if I go back and do another white balance again. And I'm back. Okay, hold on. How's that over there? No, it's not. Yeah, if I say let's see where this is going. Okay. Let's move that histogram over.
All right, I am gonna go shoot for something different. Stop stacking. And we're gonna keep going.
What? Bam. Oh,
Let's see.
I'm gonna go for the center of all this right here. Take me out that because that's okay. Now,
Well, that's awfully bright. Wonder what that could be, huh? All right, let's see if we can work with this here.
A street light.
It's a street light. No.
huh.
Is that Jupiter coming up?
That is
Ah,
through the trees. This is the wrong camera to put this on, but right. Oh, I can hear a fox in the background.
hmm.
Almost can make out cloud belts.
Yeah.